Alaikum wa rahmatullahi wa barakatuh and good day for everyone. My name is Amenah Zaid. I'm from Iraq. Uh, Today I'm going to present my research proposal titled Effect of Desmos-based activities elegant with Bloom's digital taxonomy on students' achievement and engagement in coordinate geometry. This study aims to explore how we can better utilize technology to improve mathematics learning in the third intermediate stage. Let's begin with the problem. Coordinate geometry is a central topic in school mathematics, yet research shows that students' achievement in this area is relatively low. A major issue is that students struggle to connect algebraic expression with geometric graphs. For example, understanding which slope looks like or interpreting the concept intercepts. These difficulties are often worse by traditional chalk and talk teaching methods that prioritize memories over deep analytical reasoning. While we have access to dynamic visualization tools like Desmos, they are often underutilized or used superficially without a solid instructional framework. My research addressed this gap by integrating Desmos with the systemic cognitive framework. The gap, there is a need to integrate dynamic visualization with higher order cognitive frameworks like Bloom's digital taxonomy to move beyond basic procedural skills. Theoretical framework. The study emphasizes scaffolding learning environments where students engage in complex cognitive processes, which is particularly relevant for technology-rich settings. Also, moving from lower order skills, which include remembering and understanding faces, to higher order skills like analyzing and evaluation using digital tools. So, to achieve this study is guided by 5 specific objectives. The objectives, first of the objective is assess students' current achievement and conceptual understanding in coordinate geometry. Also develop Desmos-based activities elegant with Bloom's digital taxonomy focusing on understanding, applying, analyzing, and evaluating. The third objective measure the impact of these activities on achievement, problem solving, and reasoning skills. Examine engagement. The fourth one, explore students' experience and perceptions of the Desmos-based learning environments. The last one, compare results between Desmos-based instruction and traditional method. To achieve these objectives, I have adopted a quasi-experimental explanatory sequential mixed method design. I choose a quasi-experimental approach because in authentic school settings, it is usually not feasible or ethical to randomly assign individual students. We must work with intact classes. This is explanatory sequential design because I'll collect the cognitive data first, test scores, and then use qualitative data interviews and reflections to explain why those results occur. This combination allows me to understand not just if the intervention worked, but how it influenced the students' learning. Then the mixed method rational will include quantitative and qualitative phases. So in quantitative phases, I'll measure the achievement gains and its effectives by students. And the qualitative phase, which explain how and why the intervention worked on students. So this is a process based. Also, the qualitative data helps to explain patterns observed in the quantitative result, why high engagement led to better scores. Then, the target population is all third to intermediate grade 9 students studying coordinate geometry for the sample. I will purposefully select a school that has the necessary technology access. For there, I'll select two intact classes totaling 100 students. 50 students will serve as the experimental group, then 50 students will serve as the non-equivalent control group. After the intervention, I'll select a smaller subsample of students, including high, moderate, and low gain linears, to participate in the qualitative phase. The instructional design, the intervention, the core of this study is the intervention. I'm using the ADIE model, which is included 5 phases that are analysis, design, development, implementation, and evaluation to systematically develop 10 Desmos-based activities. These activities align with the curriculum and Bloom's taxonomy. For remembering and understanding, we use activities like card sorts to match ordered pairs to quadrants. For applying, we use activities where students manipulate sliders for variables M and B in linear equations to visualize changes in real time. This moves students beyond calculating formulas to actually visualizing the math. Now the instrument of the research. To measure the impact, I have developed an achievement test elegant with the third grade textbook. The test consists of 25 items divided into 3 sections. Section A, multiple choice questions for basic recall. Section B, short answer questions for application, and 5 structures problem solving for analyze and evaluating phases. To ensure the quality of the test, the content validity will be verified by 5 experts and reliability will be established through a pilot test with 30 students. I'm mining for Kropach alpha of 0.70 or higher. Next, the data collection procedure of this research follows a static timeline. Both groups will take the pre-test at the beginning of the study to establish baseline. During the 6-week intervention, the experimental group will use Desmos activities while the control group learns via traditional methods during this time. I'll also take structures observation notes. After the unit is finished, both groups will take the post-test. Finally, I'll collect qualitative data by questionnaire and written reflection by the students on the experimental group. To analyze the data of the study, we have 2 types of data, which is quantitative and qualitative. So, for analyzing the quantitative data, I'll use descriptive statistics and the Sharpio-Wilk test for normality. I'll use independent sample t-test to compare the post-test scores between the 2 groups. I'll also use repeated measure ANOVA to see if the Desmos activities specifically improved higher order thinking skills or not. So also we use the effect size coherence test, and also we use repeated measures ANOVA to analyze gains in higher order thinking skills. To analyze the qualitative data, I'll analyze the open-ended responses using purine and caloric thematic analysis. This involves coding the data to find themes that explain the students' experiences and engagement. The expected findings achievement. Based on the literature, I expect the experimental group to show a significant improvement in both test scores compared to the control group. Specifically, I anticipate that will outperform the control group on higher order task analysis and evaluation phases because the dynamic visualization helps bridge the gap between abstract algebra and geometry. Also expected a moderate to high effect size for intervention. The last one, it's about conclusion and next step for the study. In conclusion, this study argues that we need to move beyond simply have technology in the classroom to using it with a clear pedagogical purposes. By combining this MOS with Bloom's digital taxonomy, we can transfer coordinate geometry from a difficult abstract topic into engaging visual learning experience. So my next steps in this study, I'll complete pilot testing, launch intervention in selected schools, and begin data collection. Thank you for your time and welcome your مع السلامة.